Hi everyone, welcome to week 8. This week we probably have the most chapters we've had to work with, but the nice thing is that they all do work together in a nice format, so they all kind of combine together. That being said, this week you are working with chapters 53, 54, and 55. For the day 1 video, I'm only going to talk about chapter 53 and 54. And I'm going to do them in a reverse order. So I'm going to start with 54, then discuss 53. So for chapter 54, it's talking about pharmacology. And pharmacology is the study of medications and drugs, including their forms, intentions for use, and effects. In Module 7, we started talking about the classifications of drugs and learning what those different drugs are and if they're used for children or adults. But what we did not discuss when we talked about medications was the different types of drug names that they can be called by. Drugs typically have 3 different names. They have a generic name, a brand name, and a chemical name. A generic name is the official name for a drug. When it is written out, it's typically written in all lowercase letters, and it is the legal name for the drug. The brand name is a typical name given to a drug by a specific manufacturer. The first initial of the drug will be capitalized, and everything else will be in lowercase letters. And the chemical name. Now, this is a chemical formula name for the medication the manufacturers and the pharmacists both use. So let me give you an example. If you go to the drugstore or Walmart or Target, wherever you go, and you see the word acetaminophen on a box, it's all lowercase letters, that's the generic name for the medication. Tylenol, which has the first letter capitalized, is the brand name for the medication. And the chemical name for Tylenol or acetaminophen is N-cetamide. So you get to see all 3 different types of names in one medication. Also in week 7, we did not really talk about how medications are administered, just that there were medications in different classifications. So there are different routes that a medication can be administered. And the route of how it is administered is the method by which the drug actually is introduced to the body. For example, that could be oral, parenteral, sublingual, inhalation, topical, drops, or suppositories. Now, you're used to me normally breaking all of those down and describing each one of them to you, but I'm not going to do that for the day 1 video, because day 2 we'll be talking about medication administration, and I'm going to talk about those again tomorrow in the day 2 video. So hang tight and you will see that coming next in the day 2 video. The last piece of this chapter that I really want to talk about is learning how to read and write prescriptions. As a medical assistant, part of your job will be to actually set up those prescriptions for physicians and know how to actually read them to explain them to patients. You have to understand how to read the symbols, read the different parts of a prescription pad, and use the abbreviations that are appropriate. Now, we learned about abbreviations in week 7, so make sure you have that worksheet we worked on handy so you can actually be able to go back to that for reference. Now, with prescriptions, it's also important to understand the different parts of a prescription. You have your you have the superscription, the inscription, the subscription, the signa, the physician's name, address, phone number, and DEA number, the number of refills that are to be given, and the dispense as written line. Let's take a closer look. So the superscription is where you'll find all the patient information. You'll find the patient's name, their date of birth, you will find their address, and you will find the date that the prescription was written. The inscription gives the name of the medication and the dosage that is to be dispensed. The subscription is the amount of medication that the pharmacy is to dispense to the patient. The SIG or SIGNA is the instructions for how the medication should be taken. The physician's name, address, and phone number kind of makes sense. You have to have that on all scripts. And then the DEA number is the Drug Enforcement Agency number assigned to the provider that states they are able to prescribe, dispense, or administer controlled substances. This does not need to be on all prescriptions, just the ones for controlled substances. And the last line is the dispense as written line, or the DAW, D-A-W. This states whether a generic medication can be given as a substitute or if it's brand name only. So in the lab this week, we're actually going to be practicing writing out prescriptions. So be prepared, bring that abbreviation worksheet with you, and make sure you read chapter 54. All right, let's switch sides now and talk about chapter 53. And this chapter is the chapter that gets students all riled up. It's the chapter on math for pharmacology. I don't want you to panic. I know some of you are going to tell me how much you hate math. I hate math too. But it's something very easy, very simple that we can all do. So we'll be practicing this a lot in the lab this week. Please make sure you bring a calculator or your phone or your laptop or your tablets are all fully charged because you're going to need the calculator on those. We use math in pharmacology by calculating drug dosages. We will use addition and subtraction, multiplication and division, fractions and decimals. We're going to use the full gamut of math here. There are two main methods that are used to calculate drug dosages. They're called apothecary method and metric method. Now, most physicians use the metric system, but it's really important that you as a medical assistant understand both apothecary and metric. I'm only really going to focus on the metric method for this video. It will be your responsibility to read up and bring any questions that you have about the apothecary method. So the metric method system is the most commonly used system for dose calculations and conversions. It will use the prefixes kilo, hecto, deca, your base unit, deci, centi, milli, and micro. Your metric system uses conversions that are accomplished by multiplying or dividing by 1,000. Or, in other words, that would be moving the decimal either right or left 3 places. The common metric units used for measurement are a liter for volume, gram for weight, and meter for length. In the metric system, dosages are written as a decimal number first, then the unit of measurement. For example, 25 milligrams. The decimal 25 comes first, milligrams is the measurement coming in second. So let's dive into a deep discussion about dose calculations or drug calculations. There are really many factors that are involved when physicians are calculating the correct dose of a drug. That include the age of the patient, the weight of the patient, their current state of health, and any other medications that they are currently taking. The first step with drug calculations is to confirm that the systems of weight and measurement are the same as the supply on hand. Now, if they are different, you will need to do a conversion to make them into the same unit. So what I mean by that, for example, let's say that we have an order that says we're to give 25 grams of a medication, but the supply that we have on hand is 25 micrograms. You would need to do a conversion to convert the grams to milligrams, because you always want to make sure that your order matches what you have on hand. There are two methods that we use for dose calculations. That method is the ratio method and the formula method. Ratio method means that we establish a relationship between two quantities. It will compare the drug ordered to the amount on hand. Formula method, on the other hand, uses a simple formula to determine the amount of drug needed, the drug needed in the order. So for example, your desired amount or the ordered amount would be divided by the dose on hand. That answer would then be times by the quantity of the supply on hand. I know, I get it. These are very confusing to try to explain via these videos. So I don't want you to panic. We will be spending a great deal of time going over many worksheets and doing them together in class so we get a good understanding together of how to do these dose calculations. The last thing that I want to talk about for Chapter 53 is I want to discuss the ways that you calculate dosages for pediatric patients. Pediatric medications and their doses are very different from those of adults. And there are several rules or laws that you must follow in order to calculate drug dosages. Those are Clark's rule, Freed's law, Young's rule, and the West nomogram. Clark's rule states that you base the dose calculation on the weight of the child versus the weight of an adult. And it really is the most common calculation for drug dosaging in children. Freed's law says that you apply this to children who are under the age of 1. And opposite of that, Young's rule is used for children who are over the age of 1. And then the West nomogram will actually be based off of the child's BSA, or body surface area, as opposed to that of the adult BSA. And you won't do a whole lot of dosing for children, so I don't want to spend a lot of time talking about that. But you will do a lot for adults. So I'm going to go ahead and stop the video here. We will do a lot of in-class work this week, so come in prepared, guys. It's going to be a busy 2 days like it was in week 7. Have a wonderful week, and I'll see you on day 1 of week 8.